Today we're going to be building bridges with ASCEUH. We are the American Society of Civil Engineers, and today we're going to be making a bridge. You only need 3 materials to construct your bridge. First, marshmallows. They can be any kind or any size. Spaghetti, again any kind or any size. And lastly, some weights. These weights will be used later to test your bridge. For our bridges, we used marbles, but you can also use washers or coins or anything you have lying around the house that can be used to weigh down your project. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 35, 36, 37, 38, Watch the bridge bend when it's placed under loading. This is caused by a bending moment caused by the loading of the weight. We're just going to slowly add more weight until we're able to collapse our bridge.
Something about like the way that the marbles hit the road is also kind of like when cars move.
Mm-hmm.
And some way about how we're distributing the weight evenly over the surface. I don't know.
Another thing that might cause failure is the duration of the load. One spaghetti just snapped right here, and as a bridge experiences sustained load, it can stress the material, in our case the spaghetti, causing it to fail over a long period of time. So our bridge failed in the middle. As you can see, the spaghetti broke due to the loading that we had placed it under. This is because the bending moment is strongest in the middle, where it's far away from the supports. I wanted to explain the bending moment. So, as mentioned earlier, the bending moment equation is the point load times the distance. So, here's an example that I want to show you to explain how the moment works. If you, for example, have 3 pounds as your point load on your bridge, so you have your spaghetti bridge and your span is 8 inches. So that means the gap between the tables is 8 inches, where you have your support on either side, and then this is the bridge in between. So what you do is that you have your 3-pound point load. So let's say, for example, your bridge was holding 3 pounds, and it was able to support your 3-pound weight on this bridge. So if you want to find the moment, what you do is that you put your 3 pounds multiplied by the 4 inches, because the distance is the distance from your support to the load. And then if you have a 3-pound load and the distance is 4 inches, then you'll get a 12-pound moment, pound-inch moment. Say if you wanted to put a 1-pound weight on your bridge instead of a 3-pound, you'll get a smaller moment because you have a lighter weight, but your distance stays the same.